Welcome to the lecture series on object oriented analysis and design. Even in 80s, the requirement for storing images, storing so many things which were not fitting into that kind of a database idea was there. We have been talking about attributes. Some default attributes are there, string. We had this problem with the strings also, name. How many characters will be there in the name? Initially, the DBase 3 Plus had a limitation of 40 characters. All Indian names were truncated. Even today, that is a problem. Many Indians have their full names truncated. They themselves cannot respond correctly because somewhere somebody is calling, it does not appeal, the name is not like that. It does not make any sense. So, 40 characters limit was there. It took quite some years before that limit vanished. Whatever be the name, we will have 40 characters limit. Anything that is called a string will be 40 characters. So, we started talking about the 3 name idea, namely the first name, last name and the middle name. Whichever way they are stored, each one will have 40, but then that is not enough for us. It is still not structured because there will be 5 initials and a name for a typical Indian name. It will be like that, KVRRMS, somebody will be there. Where will we store that? So, these were all real challenges. It was not such an easy task. People have been rattling their brains as to how to make it happen. So, we simply said that let there be one first name, middle name, last name, and it has created a lot of confusion again, because we are not too sure why people will address us with the last name. If you want, I would simply tell I should be called Gopal, but then lot of people use the last name. Till today it is the same case. My publications are all written in some manner, whereas when I registered online, it will take all the 3 names. So, gradually we started doing this exercise of some manual, some automatic, put together the same name. How do I identify whether these are all from the same person? So, we started talking about indexing of the works online. Now, we are confident. It was not so evident some 7 or 8 years back. Now, it is very takes time that much time. Now, it is quite evident that it does it. Some manual intervention, is it your publication, some cross checks will come, some feedback we will have to give. Once we acknowledge it does, but we know that over a span of 7 or 8 years, these indexing methods have been doing well. They are able to locate the same author publications and cross check when there is a doubt. It happens. We do put all our work which is on the machine together. Makes sense, makes a lot of business sense. It does not halt there, it is not only publications, wherever it is there it will start connecting, but those are things which are beyond the scope of this lecture. Essentially what happens is, this particular ID is a large object. As you want more and more, we can go more and more. It is doing so many things, all of them are getting collected. Everything has pluses, everything has minuses. There will be advantages, there will be disadvantages. We have to leverage the advantages. Technology will support this. Wherever it is there, it will catch. Wherever it is possible, we will humanly check, saying that is there or not. Minimize the human content, but that is a challenge of programming. Minimize the human content remains the first challenge. That is when you are doing programming, that is when you are developing software engineering. So, over a span of 2-3 years, if 4 or 5 checks are happening, it is considered big. So many checks, automatically it should tell. So, one excuse which we have been giving is names are different, we logged in a different manner, our ID has been created differently, because these are all the simple points which we keep on telling. Essentially, the object is complex, the behavioral data is also illustrated. All that is not necessary. The behavioral data for checking on the index is only this much. I do not need anything else. It may be there in so many places, it is trackable. Social media is there, everything collating data belonging to, let us say, a particular name is the overall idea. They are doing it at their pace, at their wish, from wherever. We should know how to collate them, put them together, link them up together over a span of some years. It is possible, it is doable, whatever it is. Distinct objects may need to respond in different ways. Gradually, the more you have, the more we want. We started categorizing what is this particular article. Maybe 4 or 5 categories. The user may also do that. Some are popular essays, some are research papers. What is it that is popular essay? What is the research article? Big difference. Big debates are going on. Should a research article always have 5 sigmas and 15 integrals? What is the way in which you qualify? Very quickly, the machine should qualify, not me, not the expert. What is that content that makes you classify it? So, as we progress, I am absolutely sure that we will have much more sophisticated indexing methods. We will have much more sophistication on the domain expertise, but essentially the object is a large object. We do not want all tables to be populated unnecessarily with things which are blank spaces, but large blank spaces. Even now it is a concern, and its behavioral data is also changing. As we progress, the new applications will keep demanding 7 years of data. Now, once you start telling that memory is not a concern, we can buy as much memory, we are very quickly telling that 10 years of data. At least at the time when it was paper based, anything more than 1 year is very difficult to get. It becomes commonsensical. Now the machine is there, why not 15 years, why not 20 years, it should have been there. So that is how we keep talking about it. Now we are able to have better trackability, better features, and it is essential to understand that anything that is on the machine is first taking away from the person and humans. The maximum will go away from the human. It is a thumb rule. It is not first to relate to the human, anything that is machinized. So we started building further OODBMS concepts, integration of RDBMS and OO concepts. So RDBMS concepts were very good, simple representation. At least we will talk about in attributes. Most of the times at that point in time, what we were talking about database are things which are like this. Nice tabular column is there, you write in the book, that book is also having a table. Table remains the most dominant way of organizing the data. RDBMS just takes off from there and builds certain relationship to give a good query language, a good optimizable query. Object oriented talks about abstraction, encapsulation, objects, attributes, all that we have seen. What it permits is an evolution, the behavior will evolve. Everything else is object oriented, nothing more than that. Overloading, classes, all the earlier lectures were talking from the start to polymorphism and dynamic binding. Now we have version controlling and schema evolution. As we progress, we will build. That idea of evolution is something which is very nicely possible in object oriented analysis and design. Object I am skipping, we know what it is. Every object should have an identifier system, that is speciality about the DBMS. Every object in the database will have a unique identifier UID. It remains the same independent of the values. Now always remember that identity is quite slippery in an object, because you see a class of objects. What is my first instinct? Makeup materials. What is my first instinct of seeing this? There are 2 brands of face powder. I am not so much concerned about the brand. Then why should I talk this as a unique object? At the moment we will develop it like that. These are all brands of face powder. Anything is okay for me. I will use that, not too particular. I am not too particular as far as I am concerned, but my people here may be particular, independent of its value. So that idea of tailoring, that idea of extending, one more will come, one more will come, one more brand will come. That idea of a behavior which is specific to a context of use or a use case is very essential. That emanates from object identity. Very slippery, but we will have to do that. Object identity, two objects are identical if they have the same OID, common sense. Two objects are equal if they have the same value. They are not equal. If I get one more, it is two objects, but that can be a class. It becomes a class. It is not the same object, same OID, it becomes a class. It is a different OID, but it becomes it is the same value because another face powder of the same brand. Object identity implementation, RDBMS object identity is value based. Primary key is used to provide uniqueness. Primary keys do not provide type of object identity required in OO systems, because primary key is simply telling the attribute name. If it is there, it is a primary key, otherwise it is not there. In this table X, this is the primary key. Key only unique with the relation, not across the entire system. That is the error in RDBMS. It is unique to that particular implementation. Everything is spoken of as unique to that particular RDBMS design and the way it works. But then we want this object to be known everywhere. Good example, today we have document object identifiers. Once you get the DOI, wherever you go, it is the same document that will come, irrespective of which machine, from which place, at what time, who is accessing. As long as you have that DOI, it gives you the same thing, document object identifier. They are efficient, they are fast, they cannot be modified by the user, they are independent of the content. So, good publishers automatically generate one DOI and give a link to that, you can access it from wherever. That was the goal of object oriented, where we said that there will be different objects, there will be different requests, common object request broker architecture. Today it is giving a very good support for what is called the Internet of Things. By saying so, I am not trying to indicate that we will go back to those obsessions with the structure. Some kind of a structuring is not what I am intending, but what I am intending is with these provisions which are nicely there in OOAD, we can build more fluid and evolving systems much better, and we can talk about so many things as we progress. Methods, messages, we know the message is there. Process of identifying essential objects, essential aspects of an object and ignoring the unimportant properties. So many times I have used this term abstraction. This is what abstraction means. What is the abstraction? For this purpose, I am very confident that I need only this, I do not need others. If we can tell that, you are abstracting. What teaches that? A good mathematical discipline. Indians are very good on abstractions. So, for this purpose, I need this, I do not need this. If I can tell that, I am abstracting. That is, I know what is it that I am going to do, I know what is needed to do it. Concentrate on what an object is and what it does before deciding how to implement it. Encapsulation, information hiding, these are all done in the earlier lectures. So, it is good to have an object which is an interface plus content. Object interface is a specification, object content will tell what exactly it is happening. A good interface and a good object, we know that it is one particular uniquely identifiable exercise. In this, what is new now is called persistence, persistence of objects. That is, once created, this object is there almost forever. I might have forgotten. Even today it is the same case. Suddenly I get a doubt, a query comes, is this the paper authored by you, or is he your co-author? Suddenly I will not be able to recall. It is there in the net, but I won't know. I have to fetch. A lot of things have happened, particularly for those who have been on the net for the last, let us say 20-25 years. It is a surprise that something will crop up from unexpected corner. It is still there in the net, which I do not know. So, this is an ongoing exercise, it keeps on finding out. Persistence by marking, we said this particular object must persist, it should be there. So, we have understood that while objects can be created uniquely, they have a behavior, they have an identity, and we have a way of interfacing also, all three are coming together. Some objects are persistent, once created they are there forever. we cannot do anything. The information security people tell that anything that is created on the machine is persistent, you should not delete it. Do not do anything with that. It is created in the system, it must be there in the system. So, we have been talking about so many such ideas. In the last slide we have said the same, it improves the security. Somewhere in the slides we have said the same, advantage of encapsulation, modularity plus security. It is there, leave it, we know what it is doing. So, we have been talking about information security, cyber security. In all these ways, what is necessary to understand is the point that we can either identify that these objects are persistent, or the network will throw up saying that they are all there. What do we do? Some unexpected quarters will get something out. Give names to objects like we give names to files, works only for small sets of objects. Expose object identifiers or persistent pointers to the objects. Well, it is all the same old case. How do we know that a given object is persistent? If it is there, if it is coming back, we are not doing good systems. You should tell it is there and get it. That is when we are doing programming, that is when we are doing engineering. Therefore, how do we track it? There are pointers, there are so many such. I mentioned saying that in the table there is only a pointer. It may be there even if it is persisting, it is all right. Extensibility, evolution, all these I have described. So, object database management group was created exclusively to define standards for object oriented database management systems. It is essential to have standards. Standards may take time, but then you should have a standard model established by vendors of ODBMS have produced an object model that specifies a standard model, design of class libraries and applications. So, these are all the things that are being done by object data management group. Major components of ODMG object model, please understand that it is at least 3 to 4 times usually more expensive to adhere to a standard. But then if you adhere to a standard, it is at least an increase of the lifetime of this exercise by 10 to 15 years. The choice is yours. So, that is how it is. If it is not adhering to a standard, you will have more troubles very soon. Object model, object definition language, object query, it is almost commonsensical when we talk about purchasing a car, an automobile, it is an engineered product. We know we have made compromises, art of compromise is essential, but then how do we proceed further? So, please adhere to the standards wherever they are there. Many cases innovation outpaces standardization. So, that is why we keep telling that it is not necessarily confined, but then when there is a standard, please adhere to that. The longevity of that exercise will pay off on a longer run. Object definition language, object query language, small talk language. So, what is it that we are talking about is ODMG object model, basic modeling primitives, object literals, it has its own notations. ODMG tells that if you express it in this notation, whatever you are calling is an object, whatever you are wanting to call as a large object, complex object, behavior, please express it in this notation, we will verify whether it is in conformance with the standard or not. If it is some other notation, we would know because you are the person who has created, you give it in this notation. Very commonsensical, again standard formats help, just put it in that format, transactionally we become very easy because all too familiar format. Behavior defined by set of operations, property may be either an attribute or object or relationship. A database stores objects enabling them to be shared by multiple users. A database is based on a schema. Typical advantages of all database management systems must be available even if I use this standard. Only thing is, in addition to a query language, we will have an object definition language which tells that this is how the object is defined and this is how I work with putting objects together, because the bottom up construction is essential. I would want to put different objects together to make the big picture happen at the earliest, faster. It is a big exercise prima facie to note that anywhere in the net it will be there, but once I give a reasonably good OID, all the related things should come together in a flash. Makes sense? It appears to be a big exercise, it's been intellectually challenging. A lot of people are doing research. Object oriented database management is a very good research. ODMG, they are still evolving standards. Literal types decomposed as atomic collections, structured or null. Values of a literal's properties may not change, they do not have own identifiers. So, we have had its own terminology. ODMG's object model is a good model, it tells how to generate OID, but then it is more academic in nature. Most businesses have been telling that we will create better object models. It has provisions for a few things automatically. The object models, object types, lifetime of an object is orthogonal to its type, it does in a perpendicular direction. Transient, persistent objects, some objects are transient, most of the objects should ideally be transient. Persistent, it will come, it will stay there. Object storage managed by OODBMS. There is an object definition language which tells how to work with the object, that is the purpose. The interface is all nicely defined by the ODL. There are so many collections, you can use a pre-existing model and tell that this is how we work on that. Collection of objects have an identity, it has iterator, related things come together. They can be anywhere in theory. The network is the computer, all over the world it can be there. The OID is given, related things will automatically come in a quick time. Makes sense? It makes a lot of sense. It has its own applications. The OODBMS has become a wonderful idea, and as we keep telling, today we have tools, UML, so many tools are there, and object oriented has been there around for a couple of decades now. 5 built-in collection subtypes: set, bag, list, array, dictionary. I can have a set of objects, bag of objects that allow duplicates, list of objects, array of objects, a dictionary, unordered sequence of key value pairs with duplicate keys. So, ODMG makes provision for defining what are the defined sets. Within the defined set, you can use a simple Venn diagram and get things done. Bag, list, array, dictionary, all these are very useful, and what ODMG tells is you can define objects, collections, collectives of objects, you can simply use the set, you can do lot of things and then go ahead. ODL interface for collections. Essentially the object oriented data model, no one agreed. Object data model has one definition. Object oriented data model that captures semantics, that is how we began. Object oriented database, it is more emphasizing the persistent and shareable collection. Object oriented DBMS, it is a manager of an ODB. So, how much of data orientation are we orienting it towards a data model and object oriented, or are we orienting towards large objects? The persistent and shareable collection is focusing more on large objects, binary large objects which take away a lot of space in the tables, when not many of the table entries require that. You have to block that space and you do not know how to fill it. So, object oriented data model roughly connotes the idea which I have been telling, the book. In principle all the data is there, but I am not seeing the book at all, because I went in with my model of a book, Aho, Hopcraft and Ullman compilers, and I am not able to see in all these tables, they are all disconnected, disjointed. We have to join the tables and then understand, that is an expensive exercise. So, object oriented data model is a terminology that tells that the focus will be on semantics. Object oriented databases will be more on the persistent and shareable. All videos are there, YouTube videos are there, Facebook videos are there, so much of data, tweets are there, millions of tweets are there, they are all cross checked, verified and indexed. So, there is something that I wish to move back into the earlier slides, and this is the slide, and then what we do is make this happen. You see, semantic data models, object relational data models, object oriented data models. This was the transition. Many Puritans were refusing this combination. As I said, people are very clear what can be called relational data model, object relational data model. That combination has not been readily acceptable. Most of the times where semantics are there, we move towards object oriented data models. That is how it has been working. The data models here, it roughly means that the semantics will be object oriented data model, not object relational data model. So, going back to the full screen, they said there should be a threshold model. A definition of an OODBMS is necessary. ODMG has standardized on a few things, but it must provide database functionality, support object identity, encapsulation, part of the standardizing exercise. One more definition is there. People start talking about high level query language, support for persistence, atomic transactions, only then you call object oriented. These debates have been there. There have been wonderful commercial OODBMSs saying that this much of OODBMS is there. OO data model is easier, but then OODBMS, which has all the things incorporated, is difficult to manage and conform to the standards of ODMG, because very expensive. It is quite expensive an exercise to have this OODBMS with all these features. I have first hand working experience on Jasmine, but then there are others, Gemstone, Tasca, Objectivity, Object Store, Ontos, Versant. Jasmine is very easy, but then it is still considered very rudimentary. At the time when I was working on it, it was a very rudimentary package, barely qualifying as an object oriented. Now I think it's very sophisticated. Origins of the object oriented data, traditional database systems, semantic data models, object oriented programming, special requirements, versioning and schema evolution. All these things were covered in the earlier slides. That gives you the object oriented data model. If you add persistence, it becomes a database. If you want to have a management component, it becomes object oriented database management system. The persistent programming languages are exclusively those that connect persistent objects. Objects can be connected using ODL, interfaces can be defined, but then persistence will put together all those things in the type sets or bags or whatever it is. PPLs eliminate impedance mismatch. Some of them are persistent. We should know how to deal with persistent models. So, ODBMS cuts out everything from the main memory to the secondary memory. There is no discrepancy in the way they are mapped. It is the same, the object goes, the object comes. It is not spread across the entire storage. One object, collectively it is stored. It is a great advantage. Object referencing, DOI, OID, I mentioned a few examples. Need to distinguish between resident, non-resident objects, object referencing. There are some good benchmarks about the performance. All the databases that I have been mentioning qualify the benchmark. Ingress benchmark, databases, performance, queries, definitions, everything are essential. There are some good benchmarks. 7007 benchmark, more comprehensive set of tests and a more complex database parts based on parts of hierarchy. Eventually, we said we will have a manifesto. Complex objects must be supported. We all agree. We need videos, we need data, we need audio everywhere. The more we have, the better it is. Biometrics we need, encapsulation must be supported, types of classes, DML must be computationally complete. The manifesto goes on, proposes the following optional features: multiple inheritance, type checking, no direct mention of support for security, integrity, so many advantages including improved performance. There are disadvantages. We do not have a universal data model. We do not have that much of an experience and expertise, lack of standards, standards are still evolving, and we have a very good object oriented database design comprising all these ideas of data models, comprehensive data models. Thank you. We will meet in the next lecture.